Hi class, today we're going to talk about the precise definition of a limit. This is a tough concept to understand. So let's just take a look at the function 2x minus 1 if x is not 3 and f of x equal to 6 if x is 3. So this is the function we're looking at. Intuitively, it is clear that when x is close to 3 but not 3, then f of x is close to 5. Therefore, intuitively we can see that the limit of f of x as x goes to 3 is going to be 5. So the limit of f of x is 5 when x approaches to 3. So the question is, how close to 3 does x have to be so that f of x differs from 5 by less than 0.1? Okay, so we're going to think of it at this way. So the distance from x to 3, we write x minus 3. This is the distance from x to 3. And the distance from f of x to 5 is f of x, the absolute values of f of x, minus 5. So the problem is we need to find a delta such that f of x minus 5, the absolute values, is less than 0.1 if the distance from x to 3 is less than delta, but x is not 3. Okay? So if the distance from x to 3 is positive, greater than 0, then we have such the number. So we have f of x minus 5 less than 0.1 if 0 less than the distance from x and 3 to 3 less than delta. All right, so if I take f of x and I plug the function in, so let's say I have 2x minus 1 minus 5. That in fact is 2x minus 6. And I'm going to take 2 out, x minus 3. Okay, so you can see that right here we have the 2. Okay, now you have to think 0.1. How about we do this? So notice that if 0 less than x minus 3 less than 0.1, I'm going to take that, I divide by 2. Why do I divide by 2? It's because of that. Okay, so we see that this one is going to be 0.05 here. Okay, so let's back to my the problem previously. So I have 2 the absolute values of x minus 3 less than 2, 0.05 times 2.005, which is 0.1. Okay, so you see 0.1, that's what we need, right? We need 0.1 because that's why we want to set it to less than 0.1. Therefore, when you go back, you can plug everything in. So if I go back, I know that f of x minus 5 less than 0.1 if we have the distance from x to 3 less than 0.05. So to answer the problem, we want delta to be 0.05. So you see right here, look at the graph. You see when x is in here, f of x is in here. Okay, so we want delta to be small enough so when we get to f of x, the epsilon is small enough, so it's approaching to the limit, as delta is approaching to 3. So this is the definition, the precise definition of limit, and this is how we set up the problems. So for every number epsilon, for every positive epsilon, there is a number delta greater than 0, such that if 0 less than x minus a, the absolute values less than delta, then the absolute values of f of x minus the limit is going to be less than epsilon. So let's take a look at the graph right here. You see right here is the limit, and this is epsilon, and this is our a. Okay, so we need to find a delta that's close to a. So the limit, we have the distance from the limit, and the epsilon is going to be small. So let's take a look at example 1. We want to prove that the limit x minus 3, we want to prove that the limit of 4x minus 5 equal to 7 when x approaches 3. All right, so you can see right here, we want to find that number. We want to find an epsilon. Okay, so let's do it. And how do we set up the problem? So we want to do preliminary analysis. So we want to guess a values for delta. Okay. However, we need to set up the problem. So it's always like this. If 0 less than the absolute values of x minus 3 less than delta, then f of x in this case is going to be 4x minus 5 minus L, which is 7 in this case, less than epsilon. All right, so we're going to do some work. We have to simplify it. So you're going to take 4x minus 5 minus 7. We simplify it. We end up with 4x minus 12. So if I factor out 4, I get x minus 3. Perfect, right? So you see we have x minus 3 here, we have x minus 3 here. Okay. So because of this, we want epsilon such that if 0 less than x minus 3 less than epsilon, then 4 absolute values x minus 3 less than epsilon. Based on this, you see we have x minus 3 here and we have 4 times x minus 3 here. So based on that, you want to choose epsilon to be you want to choose delta to be epsilon divided by 4 because I do want to simplify it and make them the same. Okay. So let delta to be epsilon divided by 4. And then from here, we just work backwards. If 0 less than x minus 3 less than delta, then 4x minus 5 minus 7, this is the original, equals, so I'm just working backward to prove our limit. Less than 4 delta, but we let delta to be epsilon divided by 4. So we got it. So we got this part to be epsilon. So we proved the problem. So the limit of for x minus 5 as x approaches 3 is 7.